Hello, and welcome to Seikahan, Japan Reacts. Today we are looking at the catastrophic flood on the Nepal-Tibet border, what actually collapsed, and how Japan reacted. On August 26, 2026, a massive flood and debris flow tore through a valley on the border of Nepal and Tibet, killing more than 400 people on the Nepali side alone. Here is the strange part. The earthquake recorded that morning was not an earthquake. It was the mountain itself collapsing at around 5,000 meters, a mass so large that its impact registered on seismometers. Not rain, not an earthquake, not a bursting glacial lake. A collapse with no visible warning. So is a place that was safe in the past still safe tomorrow? Let's take it step by step. First, a quick summary of what happened. On the morning of August 26th, a slope of ice and bedrock failed on the northern side of Longtang Lurong, a 7,200-meter peak in the Himalaya. The failure point was at roughly 5,200 meters. The ice, rock, and debris crashed into the river below and became a flood and debris flow, a fast-moving mix of water and sediment that ran about 100 kilometers downstream. Towns and facilities were swept away on both sides of the border, in Nepal and in China. As of August 28th, many people remained unaccounted for. Let's look at the confirmed toll next. Here are today's 3 questions. First, if this was not an earthquake and not a glacial lake bursting, what actually happened in this valley? Second, why can a mountain collapse with no visible warning? And third, the idea that a place that was safe in the past will stay safe, does that still hold? We will take them in order. The scale of the damage. As of August 28th, more than 490 deaths had been confirmed across Nepal and China, and more than 1,500 people were still missing. Many of the missing are foreign nationals. People from more than 30 countries were reportedly caught in the flood. Japan's embassy lost contact with a family of 5. The infrastructure damage is severe. Roughly 42 kilometers of road destroyed and more than 430 megawatts of hydropower capacity knocked offline. And the disaster is not over. Debris has dammed the rivers into new barrier lakes, and both governments are watching them. If one fails, it means a second flood. Let's trace the flood's path on the map. The collapse began at roughly 5,200 meters, close to the Nepal-Tibet border. The ice and debris poured into a tributary called the Lende Kola. The debris briefly dammed the river, and when that blockage failed, the stored water and sediment surged downstream at once, amplifying the flood. That chain is inferred from satellite imagery. The torrent swallowed the Gyurong border facility on the Chinese side, then swept the Nepali settlement of Timure and the trekking hub of Siabrabisi, running down the Bote Koshi into the Trishuli River. A downstream gauge recorded the water rising 9 meters in 30 minutes. The debris flow has been reported to have reached 50 meters per second at points. Why were so many people in a remote mountain valley? The answer is what this valley is. The Gyurong Crossing is the main functioning land border between Nepal and the Tibet Autonomous Region. In 2024, about 30% of China-Nepal trade passed through it. The same road is the land gateway for the pilgrimage to Mount Kailash, a site sacred in both Hinduism and Buddhism, and late August falls in the pilgrimage season. And Siabrabasi, on the Nepali side, is the trailhead for the Longtang Valley Trek, so trekkers from around the world were staying in the same valley. Trade, pilgrimage, and tourism all run through this one gorge. That is why people from more than 30 countries were caught up in a disaster on this border. Now to the first question. What actually happened? In the first hours, this disaster was reported as a magnitude 4.4 earthquake that had triggered a glacier collapse because seismic shaking had been recorded near the border. Then the U.S. Geological Survey, America's federal earth science agency, analyzed the waveforms, and the causal order flipped. The recorded shaking was not an earthquake. It was the collapse itself, a mass of ice and bedrock so large that its impact shook the ground. The seismic waves it generated were equivalent in scale to a magnitude 5.2 earthquake, though that does not mean an actual earthquake of that magnitude occurred. About 3 hours later, a secondary collapse followed, equivalent to magnitude 4.2. How the collapse began and unfolded is still being reconstructed. Here is the unsettling part. This same valley was hit by a deadly flood just 14 months earlier in July 2025, but the two floods had different causes. The 2025 flood came from a lake that had formed on top of a glacier on the Tibetan side, a glacial lake. Floods from glacial lakes draining suddenly are the classic Himalayan hazard. That lake had been tracked in satellite imagery for 6 months, from its first appearance as a small pond. Water accumulating in a visible place is something a monitoring program can, in principle, catch. This time, what failed was not a lake. It was the mass of ice and bedrock itself. A landslide specialist wrote that there is no evidence this was a glacial lake outburst flood. A collapsing mountain face can be far harder to catch in advance than a growing lake. At least in these two disasters, the visible warning signs were of completely different kinds. That is the answer to our first question. Now for the Japanese reactions. If something like this happened at Okutama, Kamata and Kawasaki would be gone a few hours later. That is how one widely shared Japanese post conveyed the scale, by translating it onto Tokyo's own map. Japanese attention was driven at first by the 5 missing Japanese nationals, a family traveling the border road, and by footage of the Girong crossing being erased. Then, over roughly 48 hours, the most shared posts shifted from raw shock to explanation. How falling ice becomes a flood, and what exactly collapsed. Here are the posts. The flooding extends nearly 100 kilometers, a true wide-area disaster. If this happened at Okutama, Kamata and Kawasaki would be gone a few hours later. Okutama is the mountainous western edge of Greater Tokyo. Kamata and Kawasaki are dense districts down by Tokyo Bay. The most effective Japanese post on scale used no adjectives at all, just distance. Ice is a solid, so why a flood, not an avalanche? Rock and ice fell about a kilometer. That energy became frictional heat, melted the ice, and the mass turned into a flowing mix of water, ice, and debris. That was among the most careful mechanical explanations circulating in Japanese, and it answers the question most viewers actually had. I was certain the footage was AI-generated. The debris flow seemed to run upstream. Then I checked the map. The terrain really does make it look that way. Suspecting that disaster footage is synthetic is now a normal first reaction. What stands out here is that the post is the verification side of that instinct, not the rumor side. It was not those glacial lakes bursting. The glaciers across the area collapsed on a huge scale and ran down through 5,000 meters of elevation. The difference between a lake bursting and a mountain collapsing was the single most confused point in early coverage, in Japanese and in English alike. Posts drawing that line clearly were among the most shared. Put together, the Japanese conversation did something specific. It worked out the physics, translated the geography, and drew the line between a lake outburst and a collapse. Getting the scale right and getting the mechanism right. Those were the two things early coverage struggled with everywhere. And that mechanism question leads straight into the deeper story. Why can a mountain fail with no warning at all? That is where we go next. A flood that killed more than 400 people in Nepal, and the cause was not rain, not an earthquake, but the mountain itself failing at around 5,000 meters, according to the analysis so far. Ice and rock crashed into the river, the flood ran 100 kilometers, and the same valley had already been destroyed 14 months earlier by a completely different mechanism. Here is the core of this video. What we call safety has always been a line drawn from past records. The water has never reached this point, this slope has never failed. This particular collapse cannot be attributed to climate change, but the conditions that line rests on, temperature, glaciers, are measurably shifting over the long term. So would more monitoring alone solve this? Let's start with what the numbers say about these mountains. In the Langtang catchment where the collapse occurred, glacier area is disappearing more than 4 times faster than its long-term average. A study published in 2026 found the catchment lost glacier area at about 0.11% per year over the centuries before 1964 and at 0.49% per year since. That is more than a 4-fold acceleration. The same study reports warming of about 0.3 degrees Celsius per decade above 4,000 meters. One important caveat: no melting was actually documented on the slope that failed. The direct link between this collapse and warming is still under analysis. What follows is the general mechanism at work in high mountains. Our second question: why can a mountain collapse without warning? One background factor experts point to is ice acting as glue. In high mountains, ice filling the fractures in bedrock, and permafrost, ground that stays frozen year-round, helps hold slopes together. The ice literally binds rock to rock. As temperatures rise and glaciers retreat, that ice in the gaps melts and the binding weakens. And unlike water filling a lake, this change happens inside the mountain, where it is hard to detect from outside. The slope grows quietly less stable. The more of that binding ice is lost, the more likely these collapses become, and some specialists warn frequency will rise. Melting ice is one contributing factor, not a proven cause here. But it is a key to understanding how a mountain can fail with no visible warning. So did monitoring and warning systems work here? A warning saves lives only when 4 steps all connect: observation, cross-border sharing, conversion into an alert, and delivery to residents. At the very first step, this flood swallowed several river gauging stations. It destroyed the observation network itself. Second, the data has to cross the border. Nepali media report that Nepal has no standing mechanism for receiving real-time river and glacier data from the Chinese side of the watershed. Third, received data has to become an actual warning. That is not one country's problem. Nepal's own capacity to convert data into alerts that reach people matters just as much as the sharing. And finally, the warning has to reach people in time. Nothing can save the ground nearest the collapse, but downstream, where the flood arrives after tens of minutes or hours, detection and transmission speed is the whole difference. Himalayan researchers are calling for community-based early warning and cross-border cooperation. Disaster protection on a changing mountain no longer fits inside one country. The destroyed Girong crossing had already been damaged in the 2025 flood. It reopened in January 2026 after 6 months of closure and was destroyed again 8 months later, which raises a hard question. Should the same infrastructure be rebuilt in the same place? Abandon rebuilding, and you lose a corridor carrying roughly 30% of China-Nepal trade, one of the pilgrimage routes and the logistics local livelihoods depend on. That loss is certain and immediate. But roads and power plants are designed against past records: hydrology, disaster history, terrain. If the assumptions inside those records are shifting, rebuilding the same thing in the same place means accepting the same risk again. A certain loss against an uncertain risk. Redrawing the safety line means choosing between monitoring investment, revised design standards, or moving what gets built, and none of those options is cheap. Back to our 3 questions. First, what happened? Not an earthquake, not a glacial lake. A collapse of ice and bedrock triggered a compound disaster of flood and debris flow. The full reconstruction is still underway. Second, why can a mountain fail without warning? The direct cause here is not yet confirmed. But in general, as the ice binding high slopes together is lost, collapses of this kind become more likely, and they give little visible notice. Third, does "it was safe before" still hold? Past records alone no longer guarantee future safety. That is the answer this disaster forces on us. And this is not only a Himalayan story. Japan recorded its heaviest rainfall on record in Chiba the same month. No single event can be pinned on climate change, but every country's disaster standards are built on past observations, and the question of when to update them is shared everywhere. As of August 28th, search operations and Barrier Lake watches were still underway. Our thoughts are with the victims and their families. If you found this useful, please like the video and subscribe. The full write-up, sources, and the original Japanese posts are in the article linked in the description. Thank you for watching.